Hey guys, you're Maths with Daniel Dallas. Thank you all of you. Thanks. I appreciate you guys staying with me and support me on my channel because we hit 100 subscribers. That's definitely a meaningful milestone for me and this project. Thank you. I really appreciate your efforts. I really appreciate your watching time. Thank you guys. And as the feedback, as benefits for you, I'm trying to get into from GCSE into A level so that those who are finalizing those GCSE programs can get started with A level with already materials uploaded into my channel. Okay, so right now we're gonna go through logarithmic equations, and now it's gonna be medium level because before we considered some basics. We considered some rules for logs, and now you need to apply for more complicated problems. All right, let's get started. So that's definitely challenging, but however not really hard, so still possible to solve them. So we're gonna go through two equations here first of all, and pause the video, try to do by your own, and let's get started. So solve for x, giving you an answer correct to 3 significant figures, and we need to solve 3 times 7 to the power of x equals 60. All right, so the way, as you remember, first of all, we need to leave alone the left part with the power of x, definitely. So that's why we're trying to divide both sides by 3, okay? Both sides we're divided by 3 in order to leave 7 to the power of x in the left side. What about the right side? 60 over 3 is 20. Okay, so we've come to the basic log equation, and now we can apply actually log with the base 7 to both parts. Why? Because we have 7 to the power of x, and right now we're going to use the basic log rules in order to get the answer. So, as you remember, x goes before log, and log 7 will give you just 1. So that's why finally we'll get x equals to log 7 of 20. And because we need to give the answer to 3 significant figures, there are 2 ways. If you have log, let's say, xy button on the calculator, you can use that with no problem. So, for example, if you press that, you can immediately get the answer. So what I'll get, 1.5395, okay? And if you round to 3 significant figures, you just simply leave the first 3 digits and round up. So we'll get x equals to 15423SF, okay? However, and that is going to be the final answer to 3 significant figures. Okay, however, if you don't have this button, you remember that you can go using the property of log. Just remember, log AB is simply can be converted as the ratio of log with the base 10, okay, of B over log with the base 10 of A. So hopefully each calculator has this button. So that's why if you apply log to log 720, it means that you'll get log of 20 with the base 10 over log with the base 10 of 7. And now you can simply try to recalculate. So I'll try also, so log 20, and I'm dividing by log of 7. And I've got the same answer, 1.5395, all right? So that's an alternative way if you don't have this button. So if you don't have, so use the rule. Okay, use the rule, which are put here. All right, let's get to the next one. So you need to solve the following equation: 3 to the power of x equals 5x plus 2, and you need to give your answer in the form log m over log n, where m and n are rational numbers. So basically from q means you remember q rational numbers in the form a over b, where a and b actually integers, except for b cannot be 0, of course. because while is the rule. All right, so let's get started. Because you have different bases 3 and 5 and the power x, there is no way to leave like one number on the left side. However, what if you have the fraction? It's all possible, but first of all, we're gonna use the indices rule. 5 to the power x plus 2 we can represent, so 2 times 3 to the power x equals 2. So 5 to the power x plus 2, we split the power, and that's why we'll get 5 squared. Okay, so we'll get this. And now 3 to the power of x over 5 over the power of x, so we divide basically by 5 of the power x, because we definitely know it never can be 0. So that's why we're eligible to do that. And we'll get the following: 3 to the power of x over 5 to the power of x. And right now, I'm also going to divide by 2 both parts. So that's why I won't have 2 on the left side. I would rather have it here on the right side. But 5 squared is 25, so I'll go 25 over 2. Okay, I've got this. And now, what I'm going to do, I'm going to use again the properties for rules for indices. 3 to the power of x and 5 to the power of x, that's common fraction to the power of x. So I'm going to say that I can put x as the single power, because if you distribute back, you'll get 3 to the x and 5 to the x. So you return back to your original. So that's why on the right side, I still have 25 over 2. If you like, you can, but it's not recommended because you need to give the answer in the way log m, log n. So I leave 25 over 2 as it is. And what I'm going to do right now, I apply log with the base 3 over 5 first. Okay? So I apply log 3 over 5 to both sides, so that here I'm gonna leave x only, because that's again the same rule as I applied here before. Let's check it out. So x goes before, because the base and the number 3 or 5 are the same. And on the right side, I will get log with the base 3 over 5 of 20 over 2. 25, sorry, over 2. Okay. So that's x. However, we need to give the answer in the form of log with the base 10. So that's why it's right time to convert and say that using the same property that I showed you before. So we can rewrite our log as the following. So we'll get log with the base 10 of 25 over 2. And we just simply divide by the log of, with the base 10, but from the number 3 over 5. Okay, so I just squeeze a little bit. Yeah, all right, and that's going to be the final answer, because actually we reached our goal. So we wrote this, the final answer for x, in the form log m over log n, where m and n are rational numbers. 25 over 2, that stays for m, so m is 25 over 2, and n is 3 over 5. All right, so both answers completed. So here is the first one, and here is the second one. And we'll go next to the last equation. This is definitely a challenging problem, but not really, because that's challenging from the first glance. So log 2 x squared plus 1 equals 2. Let's pretend that we have something of as log with the base 2 of some expression depending on x, okay? So this is the function gx inside log. And first of all, in order to find x, first we need to find gx, so that's why find g from x. We can use the basic property, so we raise 2 to the power 2, and that's how we get gx. So that's why gx is simply 4, right? Because gx is square root of x squared plus 1, we just come back and say that x squared plus 1 can be equal to 16, because we squared up, so just squared both sides. Okay, how to find x squared? X squared is just 15. How to find x itself? Is plus minus square root of 15. You're not set to calculate, so I leave as the surd. So that's my answer in the form of surd. However, here you just remember that gx according to the rule of log, so gx should be and must be more than 0. So what about if we plug negative number? There is no violation. X squared gives you a positive number. So under the square root equation, under the square root expression is always positive, because x squared plus 1 is always positive. So x squared plus 1 is always positive. So x can be any, and it doesn't violate the inequality, the restrictions that we should have for expression for b number in the log. Okay, so that's why there is no violation, and that's the answer, hence. Okay, plus minus square root of 15. Hope you like that. So don't forget to check the zillions A-level classes if you have an intention to explore A-level math. I'll also start doing A-level, so check it out as well. So it seems to me that's okay. In next video, we'll go to harder questions. There will be some proofs for logs and more complicated equations. Stay with us.